Hey everybody, I'm back to make our second video in the pair of measurement error videos about specific cases. This case is classical measurement error in Y. And I will put the camera focus on the board so that you can see the work that I'm doing here. I'm going to use the same example that I did for measurement error in X, which is the effect of schooling on wages. But just to keep things a little bit simpler, I'm not going to log the wages since that's the variable we'll be talking about in terms of measurement error. And so we've got wages equals alpha SI star plus eta I. SI star is going to be fine this time. We're not going to have measurement error in X. But in this case, it's WI star that we're not going to have a good measure of. And so we actually observe, in this case, some other measure of wage that's correlated with the true wage. It's related, but there's some error. So our true wage is kind of buried in there. What I want us to look at then is what we can estimate. We aren't going to need to walk through a lot of p-limbs this time because it's going to be a little bit clearer what's going on as soon as we write it down. What we're actually estimating is WI regressed on SI star, which means that we should be a little bit concerned in the sense that WI star plus VI is what's on the left-hand side. The right-hand side, again, alpha SI star plus eta I. And so if we want to think about what we're going to be telling the regression to do, essentially we've got this error. All I'm going to do is I'm going to get WI star by itself over here where it should be. And then we have alpha SI star plus eta I, and we're going to need to move the VI over to the other side. Totally fine to do, subtract the same thing from both sides. And so we've got this piece, that is exactly what we're looking for, and all that's happened is we've tacked on this little extra bit. This little piece, ooh, that's squeaky, sorry. That piece, the VI, is the measurement error. And the way that the regression is going to handle it is it's going to treat this whole thing like it's one measurement or one error term. The regression can't tell which part of the unobserved variation is from the original error and which part is from the measurement error. So the regression acts like this is all one error. What will this do for estimating alpha? Well, actually, alpha is not buried over here in the error term this time. Nothing's happened to our error term that creates a problem for us. Again, if we're willing to assume that that measurement error is pretty random. What we've done is we haven't generated any kind of an endogeneity problem like we did with X, where there's stuff hiding in the error term. But the problem is we've just made the error term that much bigger, that much more variant. And so you might remember if you're subtracting means, both of these are mean 0, and so this error term, this composite error term still has mean 0. But the issue is that each of them has their own variance, and when you combine variances, whether it's addition or subtraction doesn't matter. When you combine variances, the variance of that sum or difference becomes a lot larger. And so what we've created is a situation where our error term has a lot more variance, and effectively alpha should still be unbiased, and so we're very happy about that. But we're going to have large standard errors. Things are just going to not be measured as precisely. In the extreme, you can imagine if we have a lot of measurement error and WI star really doesn't do much of a good job of measuring the wage, most of what we're going to be modeling is going to be trying to model random error, and so we'll end up with huge standard errors and a very low R squared of the regression. However, the effect of schooling on wages isn't affected here. It's still unbiased because nothing has interfered with the estimation of that specific relationship since the measurement error itself was random.